Hello again, and I'll be discussing my solution for number 3 of problem set number 2. So in number 3 we are asked to find we're asked to find current IL, which is the current that goes through this resistor. So what I first did was to simplify the circuit. Since these two current sources are connected in parallel, I could also just combine them, but since they have different directions, what I did was to subtract the smaller current source to the larger current source so that it would follow its direction. So after combining the two current sources, I redraw the circuit. So we now have 3 milliamps going up or going to this node. So in order for us to find IL, we need to find first the voltage that goes in this resistor. Since they are in parallel, all the voltages that goes in this connection would also goes in every will also go to, or will be the same for every element connected in parallel. So to find, using Ohm's law, to find Ix with Ohm's law, it would be equal to V or VL over 2000. Then for IL, it would be VL over 3000. So for this resistor here, I assigned IZ, which would be equal to VL over 6000. So these are my three equations from my three initial equations. So using to find IL, we would use KCL. So we're going to use KCL at node A, since current going in this node would be also equal to current going out of this node, and if we combine those two, we would equate it to 0. So starting from IZ, I assigned if it's going out this node, I would make it positive. So positive IZ minus 3 milliamps plus 3Ix plus Ix plus IL equals to 0. So here, but it would be hard for us to find to find the answer, because we have so many variables to consider. So going back to our previous equations, we know that they have the same VL, so we could use these equations to substitute and make the equation more equal, or we are going to use what is common in each equation. So for IZ, we know that IZ is equals to VL over 6000. Then just copy this current 3 milliamps 3 milliamps. So next would be 3Ix, which we know that Ix is equals to VL over 2000 plus Ix again VL over 2000 plus IL, which is equals to VL over 3000, equals to 0. So next would be getting VL, since it is the only variable in this equation. So what I did was to transpose this current to this side to 0. So since this is a negative value, by transposing it to the other side, it would be a positive. So after that, I would just add up all these values, all the VLs. So since they have one common variable, which is VL, I took out VL. So here, from each equation or each value, so it would give me VL times 1 over 6,000 plus 4 over 2,000 plus 1 over 3,000. So the final move would be to divide this to this side. So here, so I've cancelled this because I have divided both sides with this value, so it's cancelled here. So after that, I use my calculator to solve for this value. Then VL would give me 1.2 volts. So after that, since now we have VL and we have the resistance of the resistance that the current is flowing through, or the resistor, we could now solve for the current, which is IL. So going back to the equation, IL is equals to VL over 3000 because this resistor, this is the current that goes through this resistance. So substituting VL 1.2 volts over 3000 ohms, it would give us 0.4 times 10 raised to negative 3 amperes, or 0.4 milliamps. So thank you.